Hi, Mr. R wanted us to learn, and I, Preston,
And I, Mike,
from his 4th period chemistry class, have learned to an A level the following concepts in our chapters 13 through 14, 12 through 14 in our chemistry book. This is not an inclusive list, but our selection of concepts from each chapter that I and he will remember. So our first chapter was chapter 12, stoichiometry, and something important to stoichiometry is to remember the law of conservation. And the law of conservation states that there is no loss of matter and there's no gaining of new matter. And that's important in stoichiometry to remember that when you have an equation, both sides need to be balanced. You need to have the same amount of inputted elements as there is output.
and so for what I learned is that stoichiometry is the calculations of quantity in chemical reactions, and that chemists used balanced chemical equation as the basis to calculate how much reactant is needed or product formed in a reaction.
Alright, so the next chapter is chapter 13, states of matter, and a really interesting part of matter that I didn't learn until this year was that there's a point called the triple point of every element. For water, for example, where at the right pressure and the right temperature, all three states of that matter, solid, liquid, and vapor, can exist at the same time. And for your information, if you wanted to know, water can exist as all three states of its element at 0.61 kilopascals pressure and 0.016 degrees Celsius temperature.
And so for chapter 13, states of matter, I also learned that kinetic theory all matter consists of tiny particles that are in constant motion, and that motion of the particles in a gas is rapid, constant, and random.
Alright, so our last chapter, which was chapter 14, the behavior of gases, we learned an interesting law called Graham's law, known as he talks about effusion, and effusion and diffusion are really similar. It's where a high concentration of gas, effusion is when it's escaping into where there's a low concentration, diffusion is the same except it's within a container, effusion is when it's escaping. And Graham's law states the rate, and I quote, "The rate of effusion of gas is inversely proportional to the square root of the gas's molar mass."
Okay, and for chapter 14, that compressibility is a measure of how much the volume of matter decreases under pressure, and also another thing I learned is that if the temperature is constant as the pressure of gas increases, the volume decreases.
And that's our presentation. This has been a fun chemistry class, and have fun, Tigers.